Hello guys, so welcome back again. This is Wired Visuals. Talking to you today is Lothar Mabandla. So we're going to be talking about back to basics. Basically we talk about Linux and shell scripting. Our website is now up and running, so for each previous presentation will be found on this website for that particular week, and then the video and the actual slides will be found on our YouTube channel. So if you want to contact us or see what other services we provide, you can find us on our website. So feel free to contact us, email us. We'll be very happy to work with you. So today we are going to talk about back to basics Linux. So we're going to talk about what Linux is and what shell scripting is. We feel that this is very important as we're going to move forward on our sessions, because we thought that maybe for some people they might not be that familiar with Linux, so we'll just get to cover some of the most basic things that we feel that they'll be really necessary as we move forward. So what Linux is, it's a Unix-based operating system which is capable of handling activities and multiple users at the same time. This was developed around 1969 at the AT&T Bell Labs by Ken Thompson and Dennis Ritchie. So these guys now, they are also famous for the C programming language, and Linux is a family of open source operating systems. So this is based on the Linux kernel, which was developed by Linus Torvalds and released in 1991. So development started earlier than 1991, but it was finally released, first version, on 1991. And he actually made a part of the source code was actually an audio by Linus Torvalds on how to actually pronounce Linux. Isn't that interesting? So again, Linux, it has a modular approach. So now what it means is, if one module is down, the other modules will be working. They are not dependent on one module, that if one module is down then the whole system crashes. No. And then the main characteristics, there will be the Unix file system, and then shell scripting, and a command line. So this is the Unix shell. So we use the Unix shell to actually interact with the kernel, and then we tell the kernel what we want it to do. And some programs actually that we use every day, they make use of the shell in the background and then contact with the kernel to actually perform their activities. So Linux, in our Zoom session last week on Saturday, someone mentioned that one of our viewers mentioned that they feel that we need to touch a bit on the GNU GPL license. So we've just decided to add a small portion on it. So what the GNU GPL license is, it's basically a free software license that guarantees the end users, you and me, to study and share and modify the software. So this will be any software that has this license. So some free licenses are MIT licenses and other ones. And now the GPL license is a copyleft license. So what that means is, any derivative work from the original source code, if it had this license, is that it must be open source and must be under the same license terms. So now the Linux kernel is, for example, part of the GPL version 2. It's licensed under the GPL version 2. Now there are other versions, the version 3, that will be rectifying some amendments, and then there's the first version, version 2, version 3, and some other versions that are going to be developed as we go further, because remember, it's ongoing, the process. They keep on improving them and improving them, right? Because nothing is perfect, remember, right? So Now what we're going to cover, the architecture, the platforms, and the shell types, and what shell programming is, because shell is actually a programming language just like any other. So now everything is a file in Linux. So now we have our kernel, which lies on top of the hardware, and then we have the shell, and then the application programs. So now on the shell level, there are actually many utilities that interact with the kernel. For example, we have our theme, we have bash, we have our C shell, the K shell, the Z shell, the Bone shell, different, and the environment. We have like environment variables, and all they interact with the kernel. So these are very important. And then application programs, we have mail, and then FTP. There are many other ones. We can't mention all of them at this point. There are a lot of them. So these are just examples. And then now we have our hardware platform, and then we have our user applications, the GNU. On the top level user applications, there is the GNU-C library, the glibc, and then we have this is on the user space. And then on the kernel space, we have our system core interface, we have our kernel, and then we have our architecture dependent kernel code. Now remember, different remember Linux, it works on different devices, right? So now the kernel, it needs to have architecture dependent code, because different manufacturers, they use different architectures. For example, we have for Newman architecture, and then we have all these different architectures. So now these it's very necessary so that our code is architecture dependent. This will improve the efficiency of our kernel. And then we have now the hardware platform, which will actually interact with the kernel dependent code. And then now we have different files. We have the bin file, where we have actually our binaries that are essential. For example, we have bash, chmod, and then we have kill, and then so they are different really. And then now we have our etc folder, the sbin, the user, and then in the user we have the user includes here. We have our user includes, and then where if you're writing your C code, for example, you say maybe hashtag include standard input output, so you'll find this on the include folder. If it's not there, then you specify an actual directory where we can find it. And then we have our variables, like for example the log files here. So now this is very important. Maybe you have successfully compromised the machine, and now you want to clear the logs, so you will play around there. And then we have our temporary files. Again, you also play around with those. And then now we have our dev folder, where we have the device files, and then the home directory, where there is actually the information of our users of the system, which are not the super user. The super user, their information will be on the root directory. And then we have our opt, where we have optional software applications. Optional software applications that we have, the user is actually installed them, right? And then there's the user share, where this one on users, where they actually the manual pages. So manual pages, they are very important. I feel like they are underused, because if you properly go through the manual pages, then it will save you a lot of time on Google other search engines. Alright, so platforms using Linux, we have Android and Tizen operating systems, the Chrome OS, and then servers, the Red Hat, the CentOS server, and then other servers again, which are used in, especially in IoT environments. We have different kinds of servers, so most are Linux based. Then we have microcontrollers. So these microcontrollers will be on smart TVs and smart fridges and other small systems, or even big systems. Then we have desktops and laptops, like this one is using Linux. and then we have some commands. So we'll just go over some Linux commands and then we'll come back again. All right, so now first of all, just view the file system. We have a binary folder, what I was talking about. Okay, this is taking some time to load now, so okay, it had loaded. Okay, let's just, so now this one, there are different files in here. There are different files that we'll find in here, a lot of them. And then, so mainly you would not want to play around this folder. And then here we'll have our boot files where we have the grub, and on Linux we use the grub, and then basically it's the bootloader, right? And then now we have our etc folder. So there are also other special files in here, like for example your sources. You just go to etc apt, and then you'll sort out your aptitude so that you can download updates properly, other files. And then the home, that's where there will be the users, and then our user in this case is the guest, so that's where they'll actually get to store their files. And then we have root here, and then that's the admin's home directory. And then so this root, and then they'll get to store their files in here. And then so basically it's just about it. And then we'll just go back and see the, so now we are in the root. This is the root directory, and then so these are the files that we were seeing there. And then now I want to see their permissions. So for example, the root, it doesn't allow everyone to actually see what is inside. And you see now, they actually, people can actually see what's inside, but then they cannot execute. So we have read-only privileges, R, and then X is for execute. So permissions are shown for the actual owner. This will be the owner, and this will be the group of the owner. And then so by default a user is in the users group, right? So if I am root, and then my default group is the root group, like root, and then this is my group, and then unless I change it, and then this will be the permissions for everyone to just read and execute. But some files, they, of course, here it doesn't make sense to execute a directory, right? So what it actually means is you can open and see what's inside, but on some files that you don't open and really get to navigate inside, it will be actually executing like a program. But then on directories, that does not make sense really, right? Awesome. So basically it's that. And then so now I'll just let's go here, let's just go back. Other commands, we'll get to use them more as we now use our shell. So as you see, right? Or maybe for example, when you are moved from one directory to the other, maybe the root directory, just say cd for change directory. And then so you will get to use main pages for this, so that you actually get to see more features. Or this one, it does have a manual entry, but then we'll just use the other, or we'll just show you another command. For example, here we're using the list as LSL. So if you just want to see more options that are there, you can just say mine ls, and then it will actually get to show you the features that are there. So this is really important to just go over the manual pages, because you get to learn a lot of functionalities that are there on your system that you really you never knew about. So all right, so now we just covered part of the Linux commands. So now what we're going to cover is we're just going to move on with our slides, and then we'll talk about the shell. So now the shell, basically there are many types of shells. We have the original bone shell, and then we have bash. So bash was designed in order to replace the bone shell, and then we have the C shell, the conch shell, and many other shells. So now bash, it's a Unix shell and a command language that was written by Brian Fox for the GNU project as a free software replacement for the bone shell. So some of these shells now, they were being sold. They had some nice features, and you had to actually pay in order to use them. But bash was for free. And then so now bash is been widely used. Now it's being widely used as the default login shell for most Linux distributions, and the Apple's macOS, Mojave, and other versions. So we have our C shell, which was introduced by the BSD group. This one, it slightly resembles the C programming language, and CSH and TCSH, they are all the C shells, but TCSH is for the, it would have been now improved, right? And then most features, although they were later added to the bone compatible shells, that will be bash. And then we have the conch shell that was developed in the Bell Labs, and this was based on the bone shell source code. So this was backward compatible with the bone shell, and many features of the C shell were actually included in this shell. So some of the features again were being inspired by requests for the Bell Lab users who actually use this shell. And then now I'm just going to cover shell scripting. So now basically we're going to check our files, and then so these are the permissions that are there. And then now for example, once we see that this test.temporary.sh, the user can only read, but then they cannot what? They cannot execute. So let's just change the permission so that they cannot read it at all. So this will be changed mode, and then 7 were the owners, and then for the groups nothing, and then for everyone else nothing. And then this one we want it for the loop, right? So now we are just going to, so now you see that we're actually when we say LSL, we're actually seeing everything, but we're just concerned about loop and skip. That's the only shell program that we're concerned about, not these ones, right? So now we are just going to use a utility that's on the command line. It's very nice. We can actually use it inside with our shell scripting. We can use it again inside. This is grep, so it searches for patterns. So we'll just say anything with loop, since it's the only one with loop there, and then it will give us the output. So now we have reduced our output, so now only the owner can read, write, and execute. So let's just execute it first, and then okay. So why we're getting this now, we'll just look into it now. It's because of the shell that we're using. So it's very important. Now we're just using the general shell, but then what happens now, the reason why it did not detect is because this bone shell, it does not recognize a for loop that's in this manner. So for that, in order for it to execute it, to be executed properly, we'll just use bash. So this is our shebang. So this is our hash, and then now this is our hash, and then we're emphasizing which shell to use, and then we call it the shebang. So now we're just going to quickly save this and execute. So Shell scripting, it's an interpreted language. It's not compiler based like we'll do with C. So which means that this would take longer to actually execute compared to a similar C program, as it will be much faster for a C program than in Shell. Although this is it's quite easier to write compared to C, and some functionalities that are really nice, because we can get to use the command, that some features that have already been implemented. It will make life easier than it would in C, basically. So we'll just execute this, and now it's printing. Awesome. And then now so if we are to go back and see, we have this print working directory. It's a command that we can actually use on the command line, right? So you'll see that if we do this, and then it's printing, it's giving us the same thing. So I was just emphasizing that Shell can actually make use of all the commands that we can actually do on the command line. So it makes life easier. For example, if you were to write, maybe you would want to perform some commands repeatedly, so you'll just get to make maybe a loop or something, but just automate them with a shell script. That will make life very easy for us, right? Awesome. And now this the pipe that we're using when we used LSL and grep. So we use this to actually take output from one program and put it into a grep, so that the pipe will be actually taking output from one program and sending it as input to another program. So now this is very important, because when we're now doing our exploits, for example a buffer overflow, we need to actually write some information that is too much. It would overwhelm us trying to type it. It will take a very long time, so we just execute maybe with a Python script, and then we take the output and then push it into a C program, and then we do our buffer overflow, and then we exploit it. So that will make life very easy for us. So that's why now we're just introducing some of these concepts, so that when we're up to speed and we're together as we move on from this point. Awesome. So we've done this, and then now what we're simply going to do is we're going to change. So switch user to guest, and then from there we're just going to list our program. We want to look at the permissions that are there. So now mind, we have changed the name of the user from root to guest, right? So now the permissions, only we can see that only the owner has permissions of reading, writing and executing, but we don't have permissions. So what happens now when we actually try and view this file? It appears to be blank. See, permission has been denied for us to actually view the file, right? Even if we try and execute it, permission will be denied. So that's one of those things with changing file permissions, and then we'll just exit and go back. And then so basically this is very important. So this playing around with the file permissions, as we'll see, it's very important, because when you are not root, you don't get to perform everything, but then when you are root, you have the absolute rights and freedom to actually do whatever you want within the system. So this will be very nice for us when we get to actually exploit some machines, and then now we are root, we can actually do whatever we want to our victims, right? Awesome. Awesome. and then so you'll just get to use you'll just get to use the manual pages. And then now here, well, it's not on this program what I want to. Let's see, it's not on. So this one we have our read only. This is the read only keyword. We use this for setting a parameter to read only. If it's now read only, it cannot be changed. Unset is for unsetting, but then now when you actually try to unset a variable that is read only, you will fail and you will get an error, and you won't be able to unset. Once it has been set, it has been set. It cannot change. Awesome. All right, so basically, so there are a lot of commands. There are a lot of commands, and there's more of the shell scripting. So here we just covered a small part about it. Really, you'll find that more of the information you'll find it on HackerRank if you want to learn shell scripting and familiarize with it. But then now we'll also talk about calc. So actually, before we go on and do that, we'll just show you how to print the output of a file, not to the standard output, but to actually a file, in case you want to analyze a dump later, or you want to use another program to analyze a memory dump that you actually get, or some output of a program. And then so just call this output.txt. Right, now let's use cat to actually see our output. And then you see now this is our output of our program. If we run it again, you'll see these are identical, but now this is the output of the file, and this is how. So you would use then the greater than sign to actually send the input, and then send the output, and then for the input you would use a less than sign to actually get input from that file. Awesome. So basically this is it. There are many more features. If there are parts that you feel you don't understand, any contributions, additions, would really appreciate them a lot, and to get your opinions, so you can just leave them on the comment section, and we'll get back to you as soon as we can. Awesome. And then any questions, you just leave them like we said. And then this was brought to you by Wired Visuals and Idea Today, Business Tomorrow. So you can feel free to visit us on our website, contact us. You can find us on Facebook. We are Wired Visuals. And then so you can also find us, leave us comments or any additions, subtractions on the YouTube section, and then also on our website. And thanks a lot for joining us today. So one of our sponsors today was Soft Consultants. Thank you very much. Have a good day.